Hi. We frequently speak about oil country tubular goods, OCTG. This is a name commonly applied to identify the pipes used in the oil and gas industry. Follow me. These pipes can serve different purposes in the well, such as producing or injecting oil, gas, steam, water. We will see this later, but as a very first concept, pipes used in the oil and gas industry are tubes with a connection at each end. And according to their application, they can be classified as casing or tubing. The casing preserves the integrity of the well during its entire life, while the tubing is used either to inject or to produce fluids. To select the appropriate pipe, that is the outside diameter, the weight and the grade for each application, it is very important to understand its purpose, as the design will be specific for each particular use. Let's imagine that we want to drill a well from the surface down to 15,000 feet. Under the ground, we can find several layers with different characteristics and different properties, which make it practically impossible to reach the full depth of the well in only one shot. Hence, to achieve the final depth of the well, we need to drill by sections. And after having drilled each section, we must isolate and protect them. What do you think? How can we do that? Yes, just running casing. And this is the way we continue drilling and isolating formations until we reach our target. Based on this, there is a wide spectrum of casing strings. We will describe all of them. However, try to understand that not all the wells will have all those strings. Generally speaking, shallow wells will have just a few casings, while deep, high pressure, high temperature wells will have many more strings depending on the complexity of the sections to be drilled. Let's explain this step by step. We will start drilling our well, and the first casing to be run is the conductor. This is required to circulate the drilling fluid up to the surface without eroding the upper sediments below the rig foundations. Generally, this is a very short string, normally consisting of 1 to 3 joints, and as the loads at the surface are not severe, any pipe can eventually be used for this application. There is no need to make a specific design for it. This conductor can be driven by a pile driver that is hammering, or simply running and cementing after that section of the hole has been drilled. We continue drilling and we run what is known as surface casing. This string prevents the cave-in of unconsolidated, weaker near-surface sediments, and it fundamentally protects the shallow freshwater sands from contamination. It also supports and protects the subsequent casing strings running to the well through the wellhead. And additionally, this string provides the primary pressure control, being the support for the blowout preventer, BOP. This is a valve that allows us to control the well in the event of a sudden influx of gas. The next string to be run is the intermediate casing. It seals off troublesome formations or transition zones which could cause drilling problems, such as weak formations which lead to a loss of circulation, sliding shales, high pressure zones, depleted zones, salt formations which tend to collapse the well, and so on. One characteristic of the intermediate casing is that it never faces the production tubing. This means that later there will be another string between this one and the tubing. Continuing our drilling, we have another string that is the production casing, which is set in front of the productive interval of the well. And now you can see why the intermediate casing previously run is not in contact with the tubing. The production casing is always set facing the tubing. In this way, it must be designed to withstand all the fluid properties such as pressure, temperature, corrosiveness. This casing protects the environment in the event of a failure or damage in the tubing during the production stage, as well as allowing the production tubing to be replaced or repaired during the entire life cycle of the well. Then we have a different type of casing strings called liners. Liners do not extend to the surface of the well, but rather they are suspended from the bottom of the previous casing. There are two types of liners, the drilling liner and the production liner. The drilling liner has the same concept as the intermediate casing. That is, it isolates troublesome zones that tend to cause problems in the well during drilling, and like in the intermediate casing, the drilling liners do not face the tubing. This means that at a later stage during drilling, another string will be set between the drilling liner and the tubing. And on the other hand, we have the production liner. This is a liner set in front of the productive interval of the well, and as it is normally facing the tubing, it has to withstand all the conditions arising from the fluids in case of a failure or damage in the tubing. And finally, we have the tieback. This is a string connected from the top of the liner up to the surface of the well. It can be run after a liner has been set in the well and a previous casing shows wear produced by drilling operations. In this way, this tieback will cover the damaged area of the previous casing. Another use of tiebacks is when a large and heavy casing string needs to be run from the surface to the bottom of the well. And due to its weight, it cannot be hung by the rig. In this particular case, such long and heavy casing string is divided into two shorter and lighter strings, a liner at the bottom and a tieback at the upper part, and both of them are run separately. Well, at this point we have already drilled and cased our well, and it will keep the integrity during its entire life. Now we have to put it into production, and how can we do that? Just running the very last string, which is the tubing. All the pipes used either as casing or tubing are comprised of two different parts, the pipe body itself and the connections. And the standard way to identify them is through their dimension and mass characteristics, the steel grade, and the connection. Let's see this with an example. If we say 958 53.5 P110 TSH blue, we are naming a tubular where 958 is the outside diameter expressed in inches, 53.5 is the weight expressed in pounds per foot, P110 is the steel grade, and TSH blue is the connection. Now that we have seen these different types of tubular, let's move to the next unit and see the steel grades.